In Unit 3, Lesson 6, we're going to talk about proofs and problems with isosceles triangles. In the following diagram, line BCD is drawn. They tell us that AC is congruent to BC and that angle ACD is 136 degrees. They want to know what is the measure of angle B. So we can see that from this picture, angle X or angle B is our base angle because it's opposite our congruent sides. So the first thing we want to do is we want to do supplements to get ourselves back inside the triangle. And when we do that, we end up with an angle at C. That's our vertex angle of 44 degrees. So when we do that, if we now do 180 minus 44, that gives us our 136 again. We'll divide it by 2 because there are 2 base angles of that triangle. And we end up with a 68 degree angle for X. Now we're going to do one of our proofs with isosceles triangles. So it gives us a couple of different things here. So it says ABC is drawn. It gives us that AE is parallel to BD, B is the midpoint, and that angle E is congruent to angle D. So let's get everything down and then we'll start to work with each of our individual pieces. So we'll take a second to put down all of our givens. Try to color coordinate it as best I can. So we've got AE is parallel to BD. Tells us that B is the midpoint of AC. And then it gives us nicely that E and D are congruent. So I'm just going to mark them and move on from those two. So I'll go back to my parallel piece first here. Wrong side, sorry. So if those two lines, AE and DB, are parallel, usually we look for alternate interior angles. But we saw in class that there's one other type of angle that we can look for, and those are our corresponding angles, which we have here. The corresponding angles are at 1, down at A, and 2 at angle DBC. So that's where we're going to go for step 2. We're going to go angle 1 is congruent to angle 2. And it's almost the same reason as alternate interior, but it's going to be parallel lines form congruent corresponding angles. So that's how we're going to get our angle pair from our parallel lines in that piece. The next piece we'll deal with is our midpoint. So because B is the midpoint, that's going to tell us that BC and AB are congruent. So step 3, AB is congruent to BC. A midpoint divides a segment into 2 congruent segments. So now if we look at our picture, we have angle, angle, side, congruent to angle, angle, side. So our 2 triangles are going to be congruent. And we know that that's not going to be our last step because we have a CP-CTC part for CD congruent to BE. So in step 4, triangle CDB is congruent to triangle BEA. And we said angle, angle, side was our pattern. And then to finish this off, CD is congruent to BE. And our reason for that is going to be CPCTC. So once we get our 2 congruent triangles, we have our CPCTC piece. In the next one, in the following diagram, it is known that AB is congruent to AC. So that gives us our isosceles triangle. Angle BAC is 30 degrees, and angle EAC is 75 degrees. Explain why AE must be parallel to BC. So this is going to be kind of how we're going to work into our future, or into our next lesson. But let's solve this first. So if we look at our isosceles triangle, we can do 180 minus 30. That gives us 150. And if we take that and we divide it by 2, we'll get that each of our base angles are going to be 75 degrees. So if we want to explain why AE must be parallel to BC, we want to focus on that angle and that angle. And the reason is those two would be alternate interior if they were parallel. Well, since they are congruent, that tells us we have our parallel lines. So since angle EAC is congruent to angle BCA, and they are alternate interior angles, AE must be parallel to BC. So when you're trying to show why something's parallel, you need to find a set of alternate interior angles are congruent, or find a set of corresponding angles that are congruent, and then you can state that they are parallel. In our fourth one, in the diagram below, triangle ABC is isosceles, with AB congruent to AC, and then AD bisects BC. So we want to prove angle 1 is congruent to angle 2, which means that we probably want to prove our two triangles are congruent, and then do CPCTC. So let's start our chart here. It'll be statement and reason, and then we will continue by writing our givens. So it tells us we have an isosceles triangle, so triangle ABC is isosceles. And then it tells us what the two congruent pieces are, which in this case are AB congruent to AC. Then the other piece of information it gives us is AD bisects BC. All right, so those are our two givens. If we look at the isosceles piece, you always get two things out of that. You get your two congruent sides, which they gave us. Then you also get your two congruent angles at B and at C. I'll call them 3 and 4 since they used 1 and 2 already. So angle 3 is congruent to angle 4. Sides opposite. Congruent. Excuse me, angles opposite, not sides, sorry. Let me rewrite that. Angles opposite congruent sides in an isosceles triangle are congruent. So that gives us angles 3 and 4 are congruent. Our next piece about the bisects. Well, if AD bisects BC, that means BC is the one that's being cut in half. So that gives us BD is congruent to CD. So step 3, a bisector divides a segment into two congruent segments. So now we have enough information to prove our two triangles are congruent, and actually these should have 2 slashes. We already used 1. So we have side, angle, side, and side, angle, side in each of our triangles. So step 4, triangle ABD is congruent to triangle ACD, side, angle, side. And then our last piece will be that angle 1 is congruent to angle 2, and we will go with CPCTC. As a little extension, I made an additional piece here just to show you how to do our addition postulate. So obviously there would be a lot more given to you in this problem if this was a full proof, but I just want to show you how to do the addition postulate part. So they like to give you pictures that are slightly overlapping like this, and then they tell you that one piece of it is going to be congruent, and it's usually that little piece from there. What you need to do then is you need to state that the part of the side that it's missing, the overlapping piece, is reflexive. So just as you would do any overlapping triangle piece, we're going to have the reflexive property of congruence. So we have the two little pieces that stick out from each are congruent. We have the reflexive part that slightly overlaps to be congruent to itself, obviously. And now we're going to start our addition postulate. So we're first going to focus on AF. So we're going to take AF and we're going to add our reflexive part, which is FC. And that's going to be congruent to, well, if AF is congruent to CD or DC, we're going to start the other one with DC. So we'll take the little part of the other one and add the reflexive piece. So if you look, we took two things, AF and DC, that were congruent based on our givens, and we added the same thing to both of them. That's our addition postulate, where we take two sides that we, or two parts of sides that we already know are congruent, and we add the same thing to both of them, in this case our reflexive piece. And then what we want to do is we want to state, well, when you take AF and FC and you add them together, you get the whole side, which is AC. And then the same thing, when you take DC and you add FC, you get the whole thing, which is DF. And what are we really doing? Well, we're taking two pieces that are added together and we are substituting in the two pieces, or the whole piece, in its place. So that is going to be our substitution part of this. So a quick refresh. We're given that the small pieces are congruent. We do our reflexive part to make sure that we get our overlapping piece. We then take the two pieces, the small piece plus the reflexive, set it equal to the small piece plus the reflexive, and then we'll do substitution to get that our whole sides, AC and DF, are congruent.